Okay, example 2. It's got a particle mass 0.8 kilogram acted on by a force F relative to the origin. The position vector is given by this here. Now it's slightly blurry, sorry. So we've got R equals 2t cubed I plus 50t to the minus a half j when t is greater than or equal to 0. Find the speed of p when t is 4, the acceleration of p when t is 2, and f when t is 2. Okay, so for part A, you want the speed. Now, if I'm thinking of speed, then I'm thinking of velocity. And if I want velocity, well, if we think back now, I've got r, so I've got the displacement. If I've got the displacement and I want velocity, then I'm going to differentiate. So I'm going to differentiate displacement, and that will give me the velocity. Okay, so we can say that v equals dr over dt. So differentiate this. So if I differentiate, this one's easy to see, isn't it? If I differentiate this, I'm going to end up with 6t squared I minus 25t to the minus 3 over 2j. Okay, and you want that when t is 4. So when t is 4, put t is 4 into this, so 6 times 4 squared I minus 25 times 4 to the minus 3 over 2j. And you could just put all that into your calculator and you get 96I minus 25 over 8j. So that's velocity, but they're asking for speed. Now, if I've got the velocity as a vector and I want speed, speed is the magnitude of velocity. And remember, when we find magnitude, that's like doing Pythagoras of this. Okay, because remember, it's basically like having, if you put this onto a triangle, you've got 96 in this direction, in the I direction. I've done it too low down, sorry. And then you've got 25 over 8 in the j direction. And then speed would be this side of the triangle. So that's why I'm using Pythagoras. Okay, so I'm going to do the square root of 96 squared, finding the magnitude, plus minus 25 over 8 squared. And that comes to 96.1. So the speed is 96.1 meters per second to the minus 1. Okay, part B. Find the acceleration when t is 2. So we go back to the diagram. Remember, we've been given displacement. I now want acceleration. Well, if I know from my last question, I actually found the velocity, didn't I? And if I've got velocity and I want the acceleration, I can differentiate velocity to get acceleration. Okay. So remember so we can say for part B, acceleration is dv by dt. Okay. And I'm going to differentiate. Remember, v we found from the last question was this, from part A. What was that? So if that's v, if I want to find A, sorry, I'm going to differentiate this. So if I differentiate this, I get 12ti. What am I doing now? How can I write this? Plus 25 times 3 over 2. T to the minus 5 over 2 j. Okay. Simplify that, then you get 12ti plus 75 over 2t to the minus 5 over 2 j. And then we want now when t is 2. So when t is 2, put t is 2 into this, so you get 12 times 2I plus 75 over 2 times 2 to the minus 5 over 2j. A little bit fiddly. And you end up with 24I plus 6.63j. That's your answer for acceleration. Okay, final bit, part C. Quickly, because time's running out. So C, we've got find f when t is 2. Now f, they're talking about f equals m A. And remember in the question it told you the mass was 0.8. And we've now got A. So F is 0.8 times our expression for A, which is 24I plus 6.63 J. And you end up with 19.2I plus 5.3 J. And you can put units of newtons at the end.